An attribute is a discrete data type of counted data or a ratio of a frequency of successes compared to the whole. Attribute charts consist of only one chart, unlike the paired chart configuration we saw with continuous data. Attribute charts are less costly, but they are not as powerful as variable charts. In this lesson, we will consider two attribute control charts based on the number of defects or defectives. Under these conditions, the subgroup size will be held constant. An NP chart tracks the number of defectives. It assumes a binomial behavior and requires a fixed sample size for each lot of n. We first take the sum of all the defectives. This can be presented as a count of defectives for each lot or a percent of defectives multiplied by the number in each lot. NP bar is the total defectives divided by the number of lots. We can also use this value to find the upper and control limits. Let's consider this example. We are given the number of defectives from 30 lots of material. Each lot contains 50 samples. Therefore, N is 50. Let's construct an NP chart. Using technology, the NP chart is shown here. The central tendency is shown by the green line. The red lines show the upper and lower control limits. Note that negative calculated values for the control limits are rounded to 0. This was the case for this lower limit on this example. The number of defectives appears to be well within control. A CChart tracks the number of defects. It is based on the Poisson distribution and requires a fixed sample size. C bar is the ratio of total defects divided by the number of lots. We use this value to find the upper and lower control limits. Let's use the same data set from the previous example. We are given the number of defects of 30 lots of material. Each lot contains 50 samples. Therefore, N is 50. Let's construct the CChart. Using technology, the CChart is shown here. The central tendency is shown by the green line. The red lines show the upper and lower control limits. As we would expect, the pattern or behavior of the data is the same as in the previous example. The control limits are different since a Poisson behavior is assumed. Nevertheless, the process appears to be in control.